All right, let's go and review some things as we get started, some things that we've been talking about the last couple of lessons. Of course, a couple lessons ago was before spring break, and you don't remember anything of that. But hopefully from yesterday, we remember some things from our notes. But let's see if we can do this without looking at our notes. So see what we recall here. Did encourage you last night to spend some time studying over the terms I gave you. There's about 6 or 7 terms this all, so not a whole lot. But we said that if you're wanting to find two unknowns, you could call them x and y. And which means with two unknowns, you could make a linear equation. But by itself, one linear equation is not enough information to figure out what those two unknowns are. That one linear equation literally has an infinite number of solutions in it. So we say that a single linear equation class is indeterminate. Good, Brecken. We said that one linear equation is not enough. If you want two unknowns, x and y, you have to have how many equations, class? 2. Did you pick up on it yesterday? If you had 3 unknowns, how many equations you'd need? 3. Anyone want to hazard a guess if I had, say, 6 unknowns, how many equations I'd need? 6. Yeah, as many unknowns as you have, that's how many equations you're going to need to solve. So we said that this set of equations, in our case, we're going to keep it simple. It's Algebra 1, all right? But if you have 2 unknowns, you need 2 equations. And this set of 2 equations, we solve them together. We refer to as a system of equations. I don't know that the term actually makes a whole lot of sense unless you think like a water system refers to a whole lot of connected pipes and stuff, okay? System of equations, the equations are connected. I don't know, that's about the only way. Like normally we think of a system as a method of something, and that's not what this is. Okay, so the term system of equations. Brecken's 2 for 2. Y'all 0 for 2. All right. We said that a system ideally would give us, if we're talking about linear equations, 2 straight lines that ideally intersect. And where they intersect, class, we get our answer. Don't overthink that. That was an easy one, okay? We get an answer where the equations intersect. So if the equations intersect and we get an answer, then we would describe our system as being you read well, consistent. It looks like you peached. Did you actually look, or did you just happen to glance down as you remembered? Oh, okay, you peached. All right, so consistent system. Think of it this way. If you go to your mom and you're like, after school, Mom, can I have a cookie? And Mom says, no, you'll ruin your supper. How many of you, your mom would say, no, you'll ruin your supper? How many of you, your mom would say, sure, eat all the cookies you want? How many of you, your mom never has any cookies, so there's no point in asking? Okay, now my mom didn't either. But for the sake of illustration, okay, we'll say that there's cookies, but you say, Mom, can I have a cookie? No, you'll ruin your supper. So you go to Dad. Dad, can I have a cookie? He says, no, you'll ruin your supper. And then, of course, he finds out you already asked Mom, and she said no, and you get in big trouble. At least that's how it would have been in my house. Once you get an answer from one parent, you better not go asking somebody else. But anyway, you get one answer, right? No, no. It's still just one answer, correct? There's consistency there, right? Or, Mom, can I have a cookie? And she keeps saying no every time you ask her to have a cookie. Okay, pretty soon you just stop asking and just realize she ain't going to let you have a cookie before dinner. All right? That's consistency, right? You get one answer. What if, though, Mom, can I have a cookie? No. Well, I don't have. I don't know. I'll think about it. I don't know. Maybe so. Maybe. And you never really get an answer. And then you take a cookie and you get in big trouble for it. But she never said no. She never said yes. She never really gave you an answer at all. Well, it might frustrate you slightly if you got in trouble, considering she never even gave you a straight answer, right? And kind of like the government. They don't write clear laws and you get in trouble for things you didn't know you did. Like little kids running lemonade stands these days. But anyway, the land of the free, amen. But anyway, it seems very inconsistent when there's no clarity. Okay, so then, thinking about a system of equations, you have 2 straight lines. They run parallel, which means they're never going to intersect. But when they would intersect, that's when you would get an answer, right? So if they never intersect, you literally have an answer of no solution. We would describe that system as being inconsistent. Inconsistent. Okay, consistent, you get answer. Inconsistent, no answer. Make sense? All right. Another set of terms we had to talk about, and that was the relationship these two equations have to each other within the system. If the two lines are totally separate, distinct, different lines, whether they're parallel, whether they're intersect, they're not the same line, then we would describe those equations as being independent. They can run separately from each other. They're independent equations. Now again, the lines we describe as being distinct lines, but the equations are said to be independent. If the lines lie one on top of the other, we describe the lines as being coincident. How would we describe the equations if you have one line and then the other line is literally the exact same line? Dependent. I mean, she just said independent, so the natural guess would be the other one. Dependent, right? And for dependent equations, how many times do they intersect? Infinite number of times, right? Well, that doesn't really help us, does it? So we would still describe our answer as being indeterminate, just like we would if we only had the one equation, because technically that is kind of all you got, right? It's still just that one equation. Several terms to know. Make sure you are studying your terms. Throw that thought out there. Let's go and take a look at the math that you did last night. Page 158 at the top of the page. You did numbers 7, 8, 9, and 13. You were graphing 4 different systems of equations. So you want to have your graphs out as well. 7, 8, 9, and 13. And how did you keep track of which ones were which on here? Okay. All right. From my perspective, way up here, they all look the same. But I guess from where you're sitting, you can tell the difference between pencil and pen. I kind of, sort of, maybe can. All right. Yeah, his, maybe because of the lighting, I can see the difference on his a little bit better. And all right, let's go ahead and take a look at these together, see how we did. Number 7, 2 equations. We had x positive y is equal to 8, and we had x negative y is equal to 4. There's our system of equations. I feel like both of these equations probably would be easiest to graph if I use which method, Brecken? I feel like intercept method's really easy. So for my first equation, my x-intercept class would be 8, and my y-intercept would be 8. Okay, so that's pretty easy. For my next equation, just be careful with that negative, my x-intercept's going to be, and the y-intercept is going to be negative 4. That's the only real kicker there. Make sure we keep that straight. So when we go to graph this, and now I'm going to hazard throwing it up quickly for sake of time, and I may regret this. So you got 3, 6, 9, so 8 would be right about here. 3, 6, 9, 8 would be right about here. And so we'll get a line, something like that. And then for the next one, we've got a x-intercept of 4 would be about here. Negative 4 would be about here. And it looks like probably intersecting, this looks to be about 6, 3, but 6, 3 doesn't work. 6, 2. 6, 2 would work. And again, that was a quick check. 6 plus 2 is 8, 6 minus 2 is 4. Again, you do that quick check in your head. It looks more like 6, 3, but I already knew my drawing was going to be pretty rough, right? Considering I didn't actually use the graph grid. Did we get 6, 2 for our solution? All right, got the lines that look something like that, hopefully a little bit more accurate. Maddie, question. You got it, or didn't got it, but you understand what you did? You got it now? You sure?
No.
You're not sure. Did you use intercept method or slope intercept form the graph? You did intercept method. Did you get intercepts of 8, 0, and 0, 8? Check your graph. You've got an 8 and you've got an 8. Did you have a 4 and a negative 4? Did you perhaps have 4 and 4 with a parallel line? So you did have this line. You just didn't identify their intersection point as being 6, 2?
Well, I had 5 and 4 plus 2.
Oh, okay, so, all right, so let me tell you what Maddie's, you said you had 5 and 3/4 and 1, or 2 and 1/4? And that does add up to 8, but if you were to subtract it, it would give you 3.5, which tells you it's not quite right. But you're just trying to be accurate based on where the graph is, right? So it's possible that your line, instead of going through the center of the point, maybe if the line went through like at the bottom edge or something, you didn't line it up perfectly. And graphing is a little bit picky that way. You got to be really, really exact in your graph, or you will be a quarter off there and a quarter off there, and Yeah, so close enough that I'd probably give you credit. Now, I will say this, Maddie. In general, if it's like, okay, so I'm going to draw a quick little box here. So you had something like, let's see, if this is 5 and this is 6 and this is 2 and this is 3. This is where it should have intersected, right, at 6, 2. But you had it at 5 3/4 and then 2 1/4. Yours intersected right about here. So your line just barely missed the perfect intersection. In general, assume it's probably the perfect intersection. Check those numbers, and if they don't work, then be like, well, I'll just write down what I think it probably is. Does that make sense? Because a lot of times they work out to whole numbers, especially in Algebra 1. But yeah, it's just one of the annoying things about the graphing method. The good news is, tomorrow, I teach you a method that we get to move away from graphing. But today, we have to slog through another day of graphing to make sure we understand the foundations of this concept. All right, number 8, you had a 3x, positive y is equal to 9, and x is equal to y positive 3. What method do you want to use here, Noah? Slope-intercept form? All right, so the first equation, we just need to move over to get. All right, and then for this one, what do we want to do here? Double swap to get. Careful, if the y comes over, it would actually be negative y equals negative x positive 3, but I don't want negative y, so now we just need to change all the signs to get. There we go. Or you could have set the 3 over as the negative to get y equals x negative 3 and gotten it that way as well. So now this one's going to be a bit of a frustration to graph because we've got a y-intercept all the way up here at 9. So I'm going to give myself some room here. 3, 6, 9. And then from there we could either, Noah, rise 3, run backward 1, or we could reverse it. And instead of rising 3, go down 3, but then instead of running backward 1, run forward 1. It can be a little bit more confusing to think of it that way, but it works. We get a line that looks something like that, okay? And then for my other equation, pretty easy, the y-intercept's at
3,
negative 3. And then we need to rise,
1,
run, and then we connect the dots. It looks like it intersects right about, what I'm going to guess, is right about 3, 0. And that would check out. So yes, 3, 0 is our answer. Did we get 3, 0 for the second one? Good. And you had an issue getting this into slope-intercept form. You had it running the other direction. So your point of intersection would have been way down here somewhere. All right, questions on that? All right. And let's take a look at number 9. We have an x plus 2y equals 2 and 2x. Positive 4y is equal to 4. Maddie, intercepts or slope-intercept form? I'm sorry? Intercepts. All right, so for the top equation, what's your x-intercept? All right, and then for your y-intercept, 0, 1. So we have 2, 0 and 0, 1 for our intercepts on the first equation. All right, so 2, 0, 0, 1, getting a line that looks something like that, okay? Then for the second equation, intercepts or slope-intercept form? I assumed intercepts again, good. What'd you get for your x-intercept this time? And your y-intercept? Oh, so the same 2 points, so the same line, class. These equations are what? The lines are coincident, the equations are where mama go, you gotta go because you are still dependent on her. Where the first equation goes, the second equation goes, it is a dependent set of equations here. What's the answer though, Maddie? Indeterminate. There are literally an infinite number of solutions. It's impossible to determine which one is the correct answer. Now in Algebra 2, I'll teach you how we work with indeterminate sets. But for now, Algebra 1, we're just going to say it's indeterminate and we move on with life, okay? But there we go. By the way, remember in the past we've seen equations where like, hey, we could divide everything by a 2. If you divided everything by 2, x plus 2y equals 2, you can literally see it's the same equation, right? And so that might have been one of the clues that indeterminate. How many got indeterminate equations? They graphed the same. Excellent. Let's take a look at number 13 now, where we had a 2x negative 3y is equal to 6 and a 2x negative 3y is equal to 12. And let's see, Noah, first equation, intercepts or slope-intercept form? All right. X-intercept? 3, 0, and y-intercept? 0, negative 2. All right, so 3, 0, 0, negative 2. Gives you a line that looks something like that. All right, second equation, Brecken, intercepts or slope-intercept form? All right, and x-intercept? And the y-intercept? 0, negative 4. So here we've got a 6, 0, and a 0, negative 4. And, thoughts on those lines, class? They look like they are parallel, which means they're not going to intersect, which means this system is... Right, that's the answer, no solution, but the system is said to be inconsistent. Make sure you're studying these terms. Inconsistent system, no solution from these parallels. By the way, how could these two things that are equal not equal the same thing? And that's kind of the dead giveaway there is 2x minus 3y is 6. How could 2x minus 3y also be 12? That makes no sense. That's counterintuitive. No wonder there's no solution, right? So some little ways that you can spot, hey, if I just divided 2 out of everything, it'd be the same equation. Hey, these can't possibly make sense. Infinite solutions, indeterminate, no solution here for the inconsistent system. Questions at all on the homework? Questions at all on the homework? All right, keep some graph paper out. You can set the homework aside unless you got more room maybe to work on that paper. Let's take a look at number 10 now. Number 10, there in your textbook, same section. As we continue practicing graphing these systems, interpreting data, I will go ahead and use the graph grid now that we're done with the homework. So go and write down that system of equations on your own paper. We have a 2x plus y equals 10. And we have a y equals negative 2. All right, your seats, go ahead and graph the first equation by whatever method you deem best. One of the annoying things about graphing too sometimes is when you got a really big y-intercept, you got to draw a really tall y-axis. first equation, again, it's a little annoying to have such a tall y-axis to reach all the way up to 0, 10. And frankly, whether you did slope-intercept form or intercepts, you had to have that y-intercept, right? So, I mean, there's no getting around that. This next equation, we've looked at something like this before, y equals -2. That could be in slope-intercept form. Slope-intercept form, class, say it with me, is y equals mx plus b. Well, obviously, there isn't an x, right? There's no x. This could certainly be called the b, but there isn't an mx right here. It's not there. Well, it's been a long time since we've looked at this in algebra. Remember when we said we've got like a 7x cubed plus 2x minus 3, we said we could write plus 0x squared? Been a little while to get that descending order. Well, I also said we could do the same thing here if we don't have an x term. I could treat this like y equals 0x -2. In which case, class, clearly we have a y-intercept of -2. And a slope of 0. What does 0 slope look like? Right? This would be no slope. This is what a track athlete wants. Nice and level. So here we would rise nothing, run 1, if you want to think of it that way. And we'll get a perfectly horizontal line. Do you remember me talking about that back before spring break? We kind of looked at it with inequalities as shading either above or below this line, but similar idea here. We could treat this like a 0x, 0 slope, horizontal line. Oh, excuse me, -2, not +2. I'm sorry. I was just seeing if you were paying attention. Good job, Gavin. Gavin was screaming at his computer screen just now. -2, y-intercept. I heard you, Gavin. It's all good. All right, actually that's a lie, I didn't hear him, but you know, the spirit of Gavin called out to me, and yeah, it's a little weird. All right, so -2 should be where our 0 slope line is, and so what is the solution to our consistent system, anyone? What are the coordinates of my point? 6, -2. Is our solution. Now here we could plug this in with a 6 and a -2 and say that 12 plus -2 is 10. That checks out. Here there's nowhere to plug in the 6. There's not an x. So all you have to do is plug in the y. Does -2 equal -2? Of course it does. It's kind of an unusual problem there with a missing variable, but questions on that. Another way to look at it is if y equals -2, then x could be whatever, right? As long as y is -2. So 0, -2, 1, -2, 2, -2, 3, -2, 4, -2, 5, -2, 6, -2, 7, -2, 8. You get the idea, the x could be whatever, as long as you come back to a -2 for the y value. That's another way to think of that horizontal line. Questions on 10. It's a little unusual thing I wanted to go over with you. Questions? All right, number 12. Go ahead and put number 12 down on paper. Maybe switch to a pen so you can use the same graph grid. Blue pen stands out more from pencil than black pen does, just saying. I'll switch the chalk color here. We'll go green. Everyone in government's encouraging me to do it anyways. Here I like the slope-intercept form. I felt it was really easy to get. Intercept's really fine too. Get those same lines, Maddie? How would we describe the coordinates then of this point? I mean, it's pretty clear. Remember I told you kind of round to the nearest clean dot, but I mean, it's pretty obvious it's not going to hit a clean dot. There's no way in that short space my line got off, right? So that's got to be it. It looks like x value is about -0.5 is about what it looks like here. Kind of lines up right there. And for my my y value looks like it's about I'd say about 5.5, right ish. Let's see. Let's check here. So if I've got 5.5 plus 5 times -0.5. Well, what is half of 5, class? 2.5, but negative. So that means -2.5. So 5.5 minus 2.5. Will that equal 3? Five and a half is something, take away 2.5, are you left with 3? Yeah, okay. How about this? We said 5.5 minus -0.5. Well, minus negative always means plus, right? So 5.5 plus another half equals 6. All right, there we go. So we've checked that, yes, indeed, my answer really is -0.5, 5.5. Questions on this? Kind of a weird answer there, isn't it? Let's do another one. Number 11, there at your seats. Number 11, there at your seats. Set up a new graph grid for this one. Let's set up a new graph grid. Good news about this one is it's really kind of impossible to mess it up. Frankly, I did kind of mess it up a little. If I'd done the intercept method, I would have seen my line should have gone right through the 3. Doing slope-intercept form, you notice my line kind of missed, but it didn't matter that my line was a little inaccurate because for both lines, the y-intercept was 6. So of course, where do they intersect, class? Well, for y-intercept, so we call that points, coordinates, 0, 6. Right. So yeah, kind of hard to mess that one up when they both have the same y-intercept. Questions on this one? All right, number 14, at your seats. Number 14, at your seats. And Noah, what were the coordinates of your solution? And that is correct. Brecken, did you get the same thing? Maddie, you got the same thing? Excellent. Go on to number 18 now. Number 18 now. You're going to want to make your graph grid a little bit bigger this time. Give yourself a little bit bigger graph grid this time. guess we can't do the intercept method on that first equation, can we? We get 0, 0, and 0, 0, which doesn't exactly give us a line. For the first equation, did you get y equals negative 2/5 x plus 0 for your equation? 0 y-intercept, rise 2, run backward 5. Questions on that? The next one's even worse. Y equals negative 1/6 x plus 2 1/3. Now, it wouldn't matter so much if I weren't trying to get a point of intersection, right? If it were just about graph the line, okay, 2 1/3 approximation, rise 1, run backward 6, really not that bad. But when you got to be super detailed accurate, man, that's annoying. Here we go, Maddie. It doesn't fall right on a point, but it's really close. About what point does it look like we might have hit if we'd been a little bit more accurate, maybe? It looks like negative 10/4. Let's see if that works in the top equation. Class? Would negative 10/4 work right here? I'm getting a nod and a shake. Okay, now she decided she's going to roll with what Brecken said. All right, negative 20, positive 20. Okay, it does check out there. How about here? Negative 10 and 4. Negative 10 plus 24. Would that be 14? All right, so here's a case where, yeah, it didn't come out perfectly, but it was really close. We're like, let's just try it. I mean, maybe it is negative 10 and 1/5, 4, right? Maybe, probably I'm just a little, have a little bit of error in my graph is probably more likely, right? I'm probably more likely just to screw up as opposed to getting an answer quite that detailed. Questions on this? Are you starting to hate this? This whole graphing thing? I am. Hopefully you'll grow to hate this as well, which means tomorrow you'll be really happy to learn what I have to teach you. But to help you hate graphing just a little bit more, let's do one more. It's actually not as bad as this one was. Number 21. Number 21. And I think the green is kind of hard to see, so I'm going to stop it with the green chalk. Going green is also hard on the economy, so. The orange here. Do you see how slope-intercept form kind of fails us here, class? If I try to treat this as 0y equals negative x plus 4, divide everything, well, you can't divide by 0. That's undefined slope, which means a vertical line, and undefined y-intercept, which means no y-intercept. But it's a vertical line. So somewhere, I've got to put a vertical line. Where do you suppose I should put my vertical line, class? 4. Where x is 4, we'll put our vertical line right there. And again, another way to think of this is x is 4 regardless of what y is. So it's 4, 0, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 4, 7, 4, negative 8, right? As long as it's an x value of 4, so we get that vertical line there. The next line, of course, is pretty straightforward. And a pretty clear point of intersection here, Brecken. For 0, the x-intercept does end up being our solution to the system. Questions on this? Any questions on the graphing method of systems? Any questions there? Let's do one more here. So set up a new graph grid. Let's do 3x minus 2y equals 7. And 5x plus y is equal to 16. 3x minus 2y equals 7. And 5x plus y equals 16. First equation, not too bad, right? Any issues with the second equation, class? Brecken, thoughts? How about oh my? Would be a legitimate thought. Now, there is technically a way around this, class. You ready for this? What's the slope for this equation? Class, for this equation, what's the slope? -5/1. That's not really that big of a problem, is it? It's the 16 that's a big issue. Technically, you don't have to use the y-intercept. That just is a good starting point. It's just not good today, is it? I don't have room. Agreed? What we could do, though, is to say, well, what is the x-intercept, class? 16/5, right? Which would be 3 1/5. So what we could do is get this starting point of 3 1/5, rise 5, run backward 1, and we could technically, I guess, do it that way, and that dodges the whole y-intercept mess, and it actually intersects at a pretty easy-looking point. Now, it kind of missed on my graph, but it appears to intersect around what point, class? Looks like about 3, 1, and in fact, that is the correct answer. I made this up off the top of my head. I didn't have anything in the notes, and I solved it by the time I finished doing that, using the method I'm going to teach you tomorrow. And none of this mess, none of this wasted time, none of the inaccuracies of, well, it actually looks more like 3, 1 1/3, especially since there were thirds and halves and fifths everywhere. I mean, it wouldn't be unreasonable to think maybe it was, but we're going to be able to solve them so much more quickly, so much more accurately with what I teach you tomorrow. So that it makes you love me, like, yes, he's going to save us from this, or makes you like hate me, be like, why didn't you just teach us the easy way first? Because I needed you to understand the foundations of where these things came from. You do have 4 of these to do tonight. You can do 2 on each grid so long as you use different utensils for each. Page 158 at the top, 17 and 19. Page 158, do 17 and 19. Page 163, the review, 13 and 14. Page 163, the review, 13 and 14. You'll suffer one more time tonight with this graphing, though they won't be as bad as this one, okay? And then tomorrow, I will teach you how we can solve so much quicker, so much more accurately without any of this time and trouble. Have a great day.